Hi everybody, this is James Tompkins and welcome to another Understanding Finance Nugget, in which today I'm going to be looking at deriving the present value of an annuity. And by the way, the goal is not to be memorizing these formulas, but to understand them. And if you understand this, you won't be having to memorize any of those other related annuity formulas that they have in textbooks, like future value of annuity formula, annuity due, etc. So let's get started. Now, it is helpful, or actually you do need to understand a few other nuggets prior to this if you don't already understand these. Two rates commonly used in time value of money equations. That's the effective annual rate and the nominal or stated or advertised rate. Deriving the only single cash flow formula that exists, because we'll be using that. And deriving the present value of a perpetuity formula. In fact, the derivation of this annuity formula is going to use the perpetuity formula as a building block, if you will. So what is annuity? Well, there's an annuity, right? Equal cash flows between equal time periods that end at some point, so over a finite period of time. And the goal of this present value of annuity formula is to do what? What do you think? Well, basically to take all of these guys and crush them into one single number at one single time period. So here's my question. Does there exist an effective rate such that I would be indifferent between these cash flows at this time period and a single cash flow at that time period? Does that conceptually exist? It does, right? And that's basically what we're going to be solving for. So like I said, this derivation of this formula is going to build on you already understanding what the present value of a perpetuity is. So let's get into that. Okay, so here we have a perpetuity, equal cash flows between equal time periods going on for an infinite period of time. And in this example, let's say time 0 is today, and so the first cash flow happens one period later, whether that's a year or whatever. And let's assume the effective rate is 10%. So if these are 6-month periods, this is an effective 6-month rate, which means what? Well, 10% would be the amount of interest made from $1 after 6 months, if it were an effective 6-month rate. If it's an effective annual rate, after 1 year. So, as you understand, the present value of a perpetuity is C over R. So what's the C? That's the cash flow, so that's 100, and R, of course, is the effective rate. So all of this is worth $1,000, and is it worth $1,000 in the same time period as the first cash flow, or one period earlier? One period earlier. And how would you know that? Well, by understanding the derivation of the perpetuity formula. Now let's say we want to derive the formula for an annuity, and let's say these first two cash flows. I mean, if all I had was these first two cash flows, would that be an annuity? It would, right? Equal cash flows between equal time periods over a finite period of time. And in this case, just 2 time periods. So what I'm going to do is I'm going to call this whole perpetuity line A, and I'm going to split it into 2 parts, B and C. And specifically, B is going to be these first 200s right here. And then the line's going to continue down here at C. So all of these remaining cash flows will go right there. Now, is C a perpetuity? It is, right? I mean, it's equal cash flows between equal time periods that go on forever. And so, what is the value of C? Well, could I apply my perpetuity formula? I could, right? Which is C over R. So what's the C? 100, right? And the R, 0.1. So 100 over 0.1, that's 1,000. So all of this is true. This is $1,000, but at what time period? Well, is it the same time period as the first 100, or is it one period earlier? Well, it's one period earlier, right? So C is worth $1,000 at time period 2. Now, here's a tricky question. We've got 3 lines, A, B, and C. Which of these is the annuity? B, right? B is the only one with equal cash flows between equal time periods that ends at some point. So in this case, it's just a 2-period annuity. So what is the relation between A, B, and C? Well, we said that A was equal to what? B plus C, right? So the annuity B, here's some really tricky algebra for you, is equal to A minus C. So the annuity, basically, this guy is this whole line A minus this line C, right? And so what we have is that the present value of the annuity is basically $1,000 at time 0 minus $1,000 at time 2. But can I subtract a time 2 value from a time 0 value? I can't, right? I mean, I may as well be subtracting euros from yen, right? They may as well be two different currencies. So what do I have to do to make this subtraction? What do I have to do this $1,000 to be able to subtract it from $1,000 at time 0? Well, I have to put this $1,000 at time 0, right? I have to bring it back 2 time periods. And so, therefore, what we see is that the present value of an annuity today, or a way to think about this, is the present value of a perpetuity today minus a perpetuity tomorrow that's discounted to today. So in other words, this B, you can almost think of it as a, maybe this is my perpetuity going on forever, and I could say that this part, the annuity, the finite, is equal to the whole line minus the C, the line that continues later on. And if you can understand breaking that line into 2, then you really understand the crux of this formula. So we could say that the present value of this annuity today is this $1,000 minus this $1,000, the perpetuity tomorrow, but I got to bring it back 2 time periods. So here we have the present value of the perpetuity today. Here's the perpetuity tomorrow. That's this guy. I'm discounting at 2 time periods, and boom, I have the present value of my annuity. So here's my question for you. At what time period is this $173 true? Well, at what time period was this $1,000? Time 0, right? And at what time period was this $1,000 that's been discounted twice? 0, right? So when I subtract a time 0 value from a time 0 value, what do I get? Well, a time 0 value, right? And so basically, we've just solved for the present value of annuity. These two hundreds are equal to this $173.55 at time 0. So what would you rather have? Would you rather have these 200s, given the effective rate that we made up, beginning at time 1 and then time 2, or would you rather have 173 and change at time 0? Well, if you did have a preference, it would be because, hey, I'd rather have my money sooner and spend it, or something that's feeling or emotional related, right? And but mathematically, are they exactly identically equivalent? They are, right? I mean, that's what these formulas do. They're mathematically exactly identically equivalent. So let's clean up the formula a bit. Okay, so here we have the present value of annuity is a perpetuity today minus a perpetuity tomorrow that's discounted today. So how was the 1,000 calculated? Do you remember? Well, that was the C over R, right? That was the present value of a perpetuity. And so using the numbers that we used, it was the 100 over the 0.1, right? So here we have the present value of the annuity is the 100 over the 0.1 minus the 100 over the 0.1, that's the 1,000 again, that's discounted today. And if I wanted to, could I clean this up? Could I maybe factor out these guys? I could, right? So here I've factored out the 100 over 0.1 times this 1 is what we have there, times this 1 is what we have up here. And so if we use notation, then essentially we have something that looks like that. The present value of the annuity, the C is the 100, that's the cash flow. R is is that a nominal stated or advertised rate, or is that an effective rate? has to be an effective rate, right? So if those are 6-month periods, you better be working with an effective what? 6-month rate, right? Which is the amount of interest made from $1 after 6 months. Now what about T? There's 2 right here. What does that represent? Well, we did bring the $1,000 back 2 time periods, but the reason we moved it back 2 time periods was because we had 2 sets of $100 in the annuity. In other words, T represents the number of cash flows in the annuity. Now, how are you going to convince yourself of that? Well, what you could do, let me go back a couple of slides. What you could do is you could take this line right here, and this would be a really good exercise for you to do, just to really solidify your understanding of this. Break this line up at time period 3, and then go through this whole derivation again. And what you'll find is that the number here becomes, what do you think? It'll become 3, representing the fact that there are not 2 hundreds there anymore, but 3 of the hundreds. See, these 3 guys right here. And so bottom line is that T represents the number of cash flows in the annuity. So if there's 5 sets of hundreds, then T would be what? It'd be 5, right? So like with all of these time value of money of equations that I've talked about, I've always brought up traps, if you want to call them. And the first one here is that if the first cash flow, the $100 in our example, happens at time 1, then was the solution at the same time period or 1 time period earlier? It was 1 time period earlier, right? How do you know? Well, go back to the derivation. Let's do that real quick. Go back to the diagram. The first 100 was at time period 1. But we brought everything back to time 0, right? This 1,000 was at time 0, and we brought this back to time 0. So in other words, when you apply this formula, the solution is 1 time period earlier than the first 100. So if we go back to where we were, okay, what do you think another trap is? Again, if you call this a trap, this is true of any time value of money formula. And that is essentially that the R and the T must match or correspond. What do you think I mean by that? Well, if the annuity is, say, 3-month periods, you get $100 every 3 months, then you better be working with what kind of an effective rate? An effective 3-month rate. The amount of interest made from $1 after 3 months. Now, just as an aside, notice that there are, let's see, 1, 2, 3, there's 4 variables in this formula, right? Which means any problem should be able to give you any 3 of those, and you should be able to solve for the other one, right? Well, that's true with the exception of R. In other words, I cannot algebraically rearrange this formula and say R is equal to something. And the reason for that is because there's 2 of them here. There's 1 there and there's 1 there. And so what we say is there's no closed form solution when solving for R. And this is why when you solve for R, you need a financial calculator or a spreadsheet, a software, computer, whatever, to solve for it. You cannot just algebraically rearrange this. So bottom line is that if you can understand this formula, in other words, hey, I've got this line that goes on forever. That's my perpetuity. I break it up into 2 parts. This is the annuity. This is what's left over. So, it's basically that A equals B plus C. So B equals A minus C. I mean, it's just that simple. So if you can understand and not memorize this formula, then once you've taken any annuity and you've crushed it into one single number at one single time period, are you then free to use single cash flow principles to move it anywhere along the timeline diagram you want? You are, right? So what that means is that when you look at a textbook and they say, well, here's the formula for present value of an annuity, and that's great. And by the way, here's a formula for the future value of an annuity. In this situation, if you memorize the future value of annuity formula and say this example right here, it would be giving you a cash flow one single number at one single time period at time 3. But couldn't I just understand this present value of annuity formula and then use single cash flow formulas to move it forward 3 time periods if I wanted to? Or for that matter, to move it anywhere along the timeline I wanted to, right? And of course I could. So you shouldn't be memorizing any future value of annuity formula. And by the way, the same thing holds true for what they call an annuity due. Now, do you know what an annuity due is? Well, basically, an annuity due is where they say, all right, well, imagine you get the cash flow at the beginning of the time period instead of the end of the time period. So in this example, okay, you would, could I apply my annuity formula? I could, right? I mean, is this equal cash flows between equal time periods that ends at some point? It is, right? So if I applied my annuity formula and I threw in all the variables, what would I put in for my T? Well, how many cash flows are there? Well, there's 4, right? 1, 2, 3, 4. So what would I put in for my T? I'd put in 4, right? And then when I got a solution, for my present value of annuity, so I crushed it into one single number at one single time period, then my solution, would it be at time 0 or would it be one time period earlier? Well, it'd be one time period earlier, right? So in other words, my solution would be, in this example, at time period -1. Am I then free to use single cash flow principles to move this anywhere along the timeline I want? I am, right? So for example, if I had a bunch of cash flows here and my solution was, say, I'll make something up, say, $1,000 at time -1, and the effective rate for these periods was 10%, and I wanted to know what the $1,000 was worth at time 0, what would I multiply that $1,000 by? 1.1, right? So it'd be worth 1,100 times 0. So my point is, do not memorize any annuity due formulas. Not only can you put it at time 0, you can put it in any time period you want, just by using single cash flow principles. So the point is, with this present value of annuity formula, point number 1, understand it. Think of the line that you break into 2, okay? And point number 2 is, once you've crushed all those multiple cash flows into one single number at one single time period, then you can use single cash flow principles to move it forward and back in time any way you want. And so you should therefore not be memorizing any future value of annuity formula or annuity due formula and so on and so forth. Anyway, I hope this has been helpful and look forward to seeing you at another nugget or lectures for that matter. Take care. Bye-bye.